Hello, can you hear me? Hello, Anusri. As I can see, you have joined. So, can you hear my voice?
Yes, sir.
Okay, so we will wait for a few more minutes so that more students can join, and then we will start today's discussion. So let's wait for maybe another 5 minutes. Then we will start at 7:10, and I will then.
Okay, sir.
Okay. So um, I think someone Abdul Bakar Siddiq now you have joined. So we will wait for a few minutes. Around 7:10 we will start so that more students can join. So, hello everyone. A very good evening to all. First, let me introduce myself. I am Vivekananda Naik. I am a PhD student uh, at the Department of Energy Science and Engineering, IIT Delhi. So, I am the PMRF TA of this Atomic and Molecular Physics course, which is being run by NPTEL this semester with course code NOC 26 PH18. So, since you all have registered in this course, so my duty is to take weekly interaction sessions, which will be around 2 hours, and it is scheduled at 7 p.m. to 9 p.m. on each Monday of every week. So here I will try to obviously clear your doubts so that you can interact with me. And then additionally, I will solve a few sample problems that will be again based on the lectures of this week. Like since this is first interaction session, so I will be covering the problems that will be based on week one lectures of the course, that is lecture 1 to lecture 5. So today we will cover the week one lectures, and those lectures are mainly based on experimental observations and theoretical developments in the discovery of constituents of an atom. So, where it basically explains different theory that was given by different scientists regarding the construction of an atom, like Thomson's atomic model, then Rutherford, and then in detail Bohr also gave the model. And then constituents, like we know atom has electrons, or atom has nucleus like protons and neutrons. So how these constituents were discovered? So there are different experiments then that we will that was covered in this course. The concept of Faraday's law of electrolysis, Faraday's first law, Faraday's second law, that was also discussed. Then the Millikan oil drop method to calculate the charge by mass of electron, and then J.J. Thomson's experiment, which also discovered the presence of neutron. And then, so these are the constituents that was discovered. So in detail, you have already already covered the lecture. So we'll solve a few problems. But before solving the problem, first I would like to interact with you. So can one by I think currently there are Rudolph, four students. So can one by one introduce themselves and then first say your name, then in the then what is the course you are in? So like whether you are in BSc or you are in MSc, like because I want to know about your exact background so that I will describe you accordingly. So let's start with the top one, Anusri. Can you please introduce yourself? You can unmute your mic and you can introduce yourself.
Yes, sure. Good evening, everyone. I'm Anushri. I'm a third year BSc student from Jain College.
Okay, then Lavanya. Yes, Lavanya, can you hear me? Okay, then Padmanabh Sarputkar. Can you please introduce yourself? Hello, is my voice is clear? Anyone? Anusri, can you hear me? Hello.
Yes, sir.
Okay, so I don't know why anyone else they are not in. They are not responding to my. So Swatika, can you hear me? Okay, see, let's. So it. Hello, Vijay, can you hear me?
Yes, yes.
So
Am I
can you
audible?
please inter? Yes, yes, you are audible. So, can you introduce yourself, like your name and
Okay.
your current enrolled course, like BSc or MSc?
Okay. Vijay Bhaviskar. I am the associate professor in RC Patel Institute of Technology, Shirpur.
Okay, okay, okay. Thank you. As I can see, BSc, then like Vijay said, so we will try to cover the concepts, and if some more information is required, then we will also go in depth to a specific concept. So let's start a few sample problems that uh, I will discuss in today's interaction session, and then if you have any doubt, you can ask me so that we can discuss more about some particular topics. So, like since Faraday's law of electrolysis, I was saying it was covered in this week's lecture. So let's start a problem based on not one problem. So we'll be solving a few problems. So that will be based on Faraday's law of electrolysis. So uh, 1 minute, let me first share my screen so that you can see what I am writing. So, can anyone confirm my voice is clear, or I think there might be some background noise in my case. So, is that noise is more like, are you being able to hear me clearly or not? Can you please confirm, any one of you?
Yes, sir. Yes. Uh, your voice is
So,
clear.
okay, okay. So then fine, we will start. So let me first. Okay, let me share my screen. So, can any one of you confirm? My screen is visible to you? Anyone? Can anyone currently light screen? Like
Yes,
it is a notepad.
yes, sir. Yes, sir. Screen is appearing.
Okay, okay, okay. So let's um, we will start solving a few problems. So this is week one, week one interaction session. So let's start a few problems. So question number one. So question number one says the electric charge required for the electric charge required for deposition of one equivalent of the substance on an electrode on an electrode is, so options are option A 1 ampere per 1 second, one ampere per 1 second. Option B 96,500 coulombs per minute. Option C, 1 ampere per hour. Or option D, charge of 1 mole of electrons. So these are 4 options. So the question says the electric charge required for deposition of 1 equivalent of the substance on an electrode is equal to, options are option A 1 this is 1 ampere. So 1 ampere per 1 second. Option B is 96,500 coulombs per minute. Option C is 1 ampere per hour, or option D, charge of 1 mole of electrons. So can anyone tell me? I think the deposition, the electric charge required for deposition of 1 gram mole equivalent of the substance. So what does Faraday's law of electricity say? Okay, let me. So so this is based on Faraday's law of electrolysis. So what does Faraday's law of electrolysis say? So there are two laws. So the first law says the mass of a substance deposited or liberated at an electrode during the electrolysis process is directly proportional to the quantity of electric charge passed through the electrolyte. That is first law. The first law says the mass of substance deposited. So if m is the mass of substance, then it is directly proportional to, so the mass of the is direct proportional to the quantity of electric charge passed through the electrolyte. So m is direct proportional to q, where m is the mass of, m is the deposited mass, m is deposited mass, and q is charge passed. And again, so also this relation is written as m equals to z, where what is z? Z is called as electrochemical equivalent of that substance. Electrochemical equivalent of that substance. So here the question says the electric charge required for deposition of 1 gram equivalent of the substance on an electrode is, so 1 ampere per 1 second, 96,500 coulombs per minute, 1 ampere per hour, or charge of 1 mole of electron. So the 1 gram mole equivalent means the amount of charge required is charge of 1 mole of electron. So the correct option will be option D, charge of 1 mole of electron. So 1 gram mole equivalent substance, so the amount of charge required is charge of 1 mole of electrons. Is this clear to everyone? Anyone? So should I move to the next one? Okay, so let's move to the next one. I think if I write each and every question and then I solve, it will be quite time taking or time consuming. So what I will do, so from the next interaction sessions, I will uh, mm, mm, uh, before starting the interaction session, I will be um, making a PPT where I will put the questions already. I will already put the question, and then we will start discussing it, and I will write the solutions only, so that it will be a bit faster in comparison to this way that we are uh, currently doing. So let's discuss about question number 2. So question number 2 says electrolysis of dilute aqueous electrolysis of dilute aqueous NaCl direct acute NaCl solution was carried out by passing 2 ampere of current. The time required to liberate 0.05 mole of hydrogen gas at the cathode. So option A 4825 second, option B 2830 second, option C 1956 second, or option D 38.6 second. So the question says electrolysis of diluted aqueous NaCl solution was carried out by pouring 2 sorry by passing 2 ampere of current, the time required to liberate 0.05 mole of hydrogen gas at the cathode. So the what will be the time required to liberate 0.05 mole of hydrogen gas at the cathode? So options are option A 4825 second, option B 2830 second, option C 1956 second, or option D 38.6 second. So I'll give you a few minutes. I will I will encourage you to solve this question, and then we will discuss after some times. Yes, anyone? Anyone was able to solve it? Okay, so now let's discuss the solution. So, so the first law of Faraday's law of electrolysis, what we discussed. The first law says the amount of substance deposited uh, so the mass of the substance deposited at an electrode during the electrolysis process is directly proportional to the quantity of electric charge passed through the electrolyte. So what we can write, so M is directly proportional to Q, or M equals to ZQ, where Q is the charge passed and Z, as I've already mentioned, Z is the electrochemical equivalent. So we know Q equals to IT. That's why the expression can be written as M equals to ZIT. So now we know what is Z. So Z is electrochemical equivalent. So we can write Z as M by N F. So what is M? So M is the molar mass and N is valence. And what is F? F is the Faraday's constant. So if you write the equivalent weight as E, so if E is the weight, then we can write E as M by N. So we can write Z equals to E divided by F. So if you put in this equation 1, if you use the value of Z, so from what we can write, M is equals to E I T divided by, so M is E I T divided by F. So now let's come to our question. So our question, it is mentioned the electrolysis of dilute aqueous NaCl solution was carried out, and it was carried out by passing, sorry, so this is not H2, this is Cl2. I think there is some mistake. Sorry, NaCl. Sorry, the time required to liberate 0.05 mole of H2 gas at the gas. So it is H2 only. So the time required to liberate 0.0. So now what is the mass of 0.0 mole of, sorry, the mass of 0.05 mole of H2. So what is the mass of 1 mole of H2? So we know the mass of H2 is 2 gram. So 0.05 mole. What will be the mass? 0.05 mole into 2 gram per mole. So 0.05 into 2. So what is the total mass? 0.1 gram. Sorry. So 0.1 gram of hydrogen is liberated at the cathode. So the mass liberated during the electrolysis process is 0.1 gram. Now, what is the equivalent weight? So equivalent weight of H2. So equivalent weight, what is the value of equivalent weight? So equivalent weight is atomic weight by valency. So atomic weight by valency, atomic weight. So atomic weight of hydrogen is 1 and valency of hydrogen is 1. So it is 1 only. So the uh, electrochemical, the equivalent weight of hydrogen is again 1, and then from this expression m equals to EIT by F. So F we know F is 96,500. uh, E we know m we calculated. I is also given. I is 2 ampere. So I is 2 ampere. So the expression says m equals to EIT divided by F. That implies, so what is the unknown? What we need to find out? We need to find out the time required to liberate 0.05 mole of hydrogen gas. So the time will be m into F divided by E into I, and we have all the values. So m, what is the total mass? Total mass is 0.1 gram into F is 96,500 divided by what is the equivalent weight of hydrogen. It is 1 into current 2 ampere. So if you calculate, it will be coming around, it is 1 by 20 into 96,500. So it will be 4825 second, 1 minute. Okay, so the correct answer will be 4825 seconds. So correct option will be option A, 4825 seconds. Is that clear to everyone? So the question was electrolysis of dilute aqueous NaCl solution was carried out by passing 2 ampere of current. The time required to liberate 0.05 mole of hydrogen gas at the cathode. So this is the amount of hydrogen gas that is being liberated, and the current passing is 2 ampere. So what is the total weight of the gas liberated? So we know the 1 mole of hydrogen gas is 2 gram. So 0.05 mole will be 0.1 gram. So we first calculated the mass. So the mass we calculated at 0.1 gram, and then what is the equivalent weight of hydrogen? The equivalent weight of hydrogen is 1, that is atomic mass divided by valency 1 by 1, and then the current passing is 2 ampere. And we know the constant Faraday's constant is 96,500. So if you put all the values in the expression, m equals to EIT by F, which again gets converted to T equals to MF divided by EI. So M is 0.1, F is 96,500 divided by 1 into 2. Current is 2. So if you calculate it, it will be 4825 seconds. I hope this is clear to everyone. Now we'll move to question number 3. So question number 3 says, again it is based on Faraday's law of electrolysis, the amount of electricity that can deposit 12 gram of silver from AgNO3 solution. So the question says, the amount of electricity that can deposit 12 gram of silver from AgNO3 solution. The amount of electricity that can deposit 12 gram of silver from AgNO3 solution is option A, 12 coulombs, option B, 108 coulombs, option C, 100 10722 coulombs, option D, none of the above. So the question says, the amount of electricity that can deposit 12 gram of silver from AgNO3 solution. So here you see, we need to find out the amount of charge. So there is no information about time and current, because we need to directly calculate the charge. So we will use the expression. So we will use the different way of calculation that we used in question number 2. So I'll give you a few minutes. I request you to try this, and then we will discuss in more details about the question. Yes, anyone was able to solve this question? Yes. So see, here the question says the amount of electricity that can deposit 12 gram of silver from AgNO3 solution. So now let's find out what is the gram equivalent weight of silver. So what is the gram equivalent weight of silver? Gram equivalent weight of silver. So the gram equivalent weight of silver is 108 gram. Sorry, there are some disturbances, so I had to leave. So now let's. So what is the gram equivalent weight of silver? The gram equivalent weight of silver is gram equivalent weight of silver. So gram equivalent weight of silver. So E, it is atomic weight divided by valency. So atomic weight we know it is 108 and valency is 1. So it is 108 gram. So we know the amount of electricity that can deposit 12 gram of silver. We need to find out. So for since 1 gram equivalent weight of silver is 108 gram, to deposit 108 gram of silver, we need 1 Faraday of charge. But the question says we need so 12 gram. So 108 gram is 1 farad, which is equals to 96,500 coulomb. So for 1 gram, we need 96,500 by 108 coulomb. And for 12, 96,500 divided by 108 into 12. So 12, 9. So if you calculate it, it will come out to be 9 is 107 coulomb. So it is 10722 coulomb. So the correct answer is 10722 coulomb. Option C. I hope this is clear. This was similar to the previous question, but the approach was different. Now question number 4. So question number 4 says the quantity of electricity required to liberate 0.001 gram equivalent of an element at the electrode. So the quantity of electricity required to liberate 0.001 gram equivalent of an element at the cathode. So options are option A 965 coulomb, option B 96,500 coulomb, option C 96.5 coulomb, or option D 0.01 coulomb. So since we already discussed this similar type of problem, so can anyone tell me, it is pretty easy to solve this one also. Question number 4. The quantity of electricity required to liberate 0.001 gram equivalent of an element. Yes, anyone? Yes, so can anyone tell me what will be the amount of charge required, or amount of uh, basically charge only. So amount of the quantity of electricity required to liberate 0.001 gram equivalent of an element. Yes. So just we discussed, we to liberate 1 gram equivalent of an element, we need 1 farad charge. So 1 gram equivalent is 1 farad charge, which is 96,500 coulomb. So 0.001 gram mole will be 96,500 into 0.001. So it will be 96.5 coulomb. So the correct option will be option C, 96.5. Is this clear to you? Okay, so we'll move to question number 5. So question number 5 says, during the electrolysis of molten sodium chloride, the time required to produce 1 mole of chlorine gas using a current of 10 ampere. So during the electrolysis of molten sodium chloride, the time required to produce 1 mole of chlorine gas using a current of 10 ampere is. Options are option A 19,300 second, option B 12,500 second, option C 35,500 second, option D 710 second. So can anyone tell me, during the electrolysis of molten NaCl, the time required to produce 1 mole of chlorine gas using a current of 10 ampere? So I'll give you a few minutes. So uh, so I'll give you a few minutes. Similar type of question you have already solved in question number 2, I think, and then we will discuss. So again, what is the mass of 1 mole of chlorine? Mass of 1 mole of chlorine gas, it is 71 gram. 13.5 plus 13.5, 35.5, 35.5. Now, what is the equivalent weight of chlorine gas? Equivalent weight, it is atomic mass divided by valency. So atomic mass is 35.5, valency is 1, so 35.5 gram. Therefore, T equals to mf divided by E into I. So these are the formula that we earlier used in one problem. So what will be the time required? So it will be 71 into F is 96,500 divided by E is 35.5. Current is 10 ampere. So current is 10. So if you calculate it, it will come out to be 9,300 seconds. So the correct answer is 19,300 seconds. 19,300, that is option A. So I hope this is clear to everyone. Now we move to question number 6 says again this question. So I think it will be better if you solve questions related to the Faraday's law only. And then in the next, I will try that in the next interaction session. We will solve the question related to the Millikan oil drop method and all. So the question number 6. So question number 6 says 10 farad of electricity, 10 Faraday of electricity is passed through a solution of CuSO4. The mass of copper deposited at the cathode is, so atomic weight of copper is 63.5 gram. Sorry, 63.5. Option is option A, 635 gram. Option B, 317.5 gram. Option C, 6.35 gram. Option D, 0.635 gram. So the question says 10 farad of electricity is passed through a solution of CuSO4. The mass of copper deposited at the cathode. We know 1 Faraday of electricity, if it is passed, then it deposits 1 gram equivalent of the 1 gram mole equivalent. So 1 gram mole of equivalent of copper. So what is the equivalent weight of copper? So the equivalent weight of copper is atomic weight by valency. Equivalent weight, atomic weight by valency. Atomic weight is 63.5 divided by valency is 2. So it will be 31.75. Now if we pass 1 Faraday, then 31.75 gram of copper will be deposited. If we pass 10 Faraday, then 31.75 into 10, that is 317.5 gram. So 317.5 gram of copper will be deposited if you pass 10 farad of electricity. So the correct option will be option B, 317.5. Now let's solve another one, again based on Faraday's law of electrolysis. So not exactly related, but the concept is like that only. This is question number 6 or question number 7. Question number 7. Question number 7 says, how many electrons would be required to deposit 6.3 at the cathode during the electrolysis of copper at the cathode during the electrolysis of CuSO4. Options are option how many electrons would be required. So here the question is how many electrons. So option A, 6.023 into 10 to the power 21. Option B, into 10 to the power 20. Option C, 12.046 into 10 to the power 19. Option D, none of the above. So here the question says how many electrons would be required to deposit 6.35 milligram of copper. 6.35 milligram. So now again we know the in copper the valence of copper is 2. Copper valence is 2. So actually if you calculate the charge of one n number of electrons, so it is 96,500 farad. So one Avogadro number of electron charge is 96,500 coulomb or 1 farad. So for depositing 63.5 by 2 gram of copper, we need 1 Avogadro number of electrons, that is 6.023 into 10 to the power minus 20. Sorry, 6.023 into 10 to the power 23. So now for depositing 36.5 milligram of copper. So 63 milligram will be 6.023 into 10 to the power 23 into 2 divided by 10 to the power minus 3. Sorry, divided by 10 to the power 3. That is milligram. So milligram to milligram, if you convert, we multiply 10 to the power 3 there. So here we are also multiplying 10 to the minus 3 here, 10 to the minus 3 here. 12.046 into 10 to the power 19. Sorry, so 63.5 milligram is, I think 6.35 milligram, 6.35 milligram, it will be 10 to the power 4. So to divide another 10 here, it will be 12.046 into 10 to the power 19 number of electrons required to deposit 6.35 milligram of copper. So option C, 12.046 into the power 19 number of electrons. So these are the few questions that I wanted to discuss with you, and these are based on the concept of Faraday's law of electrolysis. So I hope the questions that I have discussed will definitely help you if you are preparing, if you are solving the course assignments, as well as if you are thinking to appear in the exam for this course also. So I think this way, if I am writing the whole question and then I am doing answer, it is taking a quite long time. So what will I do? I from to starting from the next introduction session, I will first uh, mm, mm, uh, add all the questions to a PPT, and then I will solve the PPT, and I will write only answers with it. So I hope this will help you to this will help us to solve questions more quickly also. So with this, I need to end this discussion session here. So in the next interaction session, we will solve the problems based on Millikan's oil drop method, and the problem that will be based on week 2 lectures of this course. If you have any doubt, you can ask me. And regarding the course content, so the top things I am discussing here. So the things I am discussing are like this questions and solutions that I will make a PDF and I will upload to a Google Drive. I think the Google Drive link where the contents will be uploaded will has been supplied to you. Or what I will do in the next interaction session, I will make a Word file and I will show you. So there you can also see the link, as well as if someone is facing problem to join the session through the Teams link, they can join through the meeting ID and password also that I will. And if for those people who have not attended this interaction session, they can watch the recordings, which I will be uploading on the YouTube by taking the videos of this interaction session. So with this, I thank you everyone for joining in this interaction session. That's it from my side. Thank you.